All right, Internet. Hello, hello. So, we have both good news and we have bad news. So the good news is I found an application that's compatible with the new version of Ubuntu, and I can draw on the screen. Look at that. Bad news is that we weren't able to solve this challenge today. We're getting really good at failing. That's a good feeling. Reason we're unable to solve this challenge today is a similar issue that another individual has run into, a stranger, I don't know them, but they ran into it 7 days ago, and I ran into it today. So it might be a temporary issue for myself and others, or we might just be confused and not know how to solve the challenge. Either way, I understand the logic of how this challenge is solved. I'm going to walk you through that, kind of give you an explanation of what should be expected if it works for you, and that's that. So, this challenge here is called DEX. Now, DEX stands for, basically it stands for Decentralized Exchange. And this link here is going to take you out to a Wikipedia page that explains what a DEX is, a decentralized exchange. And it's basically a decentralized version of a centralized exchange. So centralized exchanges commonly, what do? So they usually have some sort of broker in the middle or some sort of balance sheet. And as you want to trade one currency for another, you send that currency in. That balance sheet says, okay, you would like X amount of this token, and I'll send that to you here. And it's all centralized to a certain location or certain company, usually that keeps tabs of what's being exchanged. Well, with decentralized exchanges, it's slightly different. So what they're going to do here is they're going to have a liquidity pool or multiple liquidity pools. So we can say this is our liquidity pool here, and inside of this liquidity pool, there's going to be a series of different types of tokens. And the liquidity providers tend to be a series of individuals or groups. So we can say all these groups are providing liquidity to this pool to be exchanged. So we say we have Alice and we have Bob, and Alice wants token 1, and Bob wants token 2. So say Alice has a bunch of token 2 and Bob has a bunch of token 1. So they can actually exchange that here. So Alice can say, hey, I want token 1, and Bob says, hey, I want token 2. They'll put that into the liquidity pool and they'll exchange it here. And instead of relying on this person putting in funds for this person, that's where the liquidity pool comes into play, because maybe Bob doesn't come along for another 3 days, while Alice wants it, in this 5 minutes, right? So if that's going to happen, then Alice comes into 5 minutes. She says, "Hey, I want token 1, and I'll purchase whatever I need to purchase to get that money back, or swap it for whatever I want to swap it for." So if I want to swap token 2 for token 1, I'll put in token 2, and then these liquidity providers here that put it into the liquidity pool, they're going to provide back what's needed for what she requested. And then Bob's going to do the same, but 3 days later. So that's kind of the premise of what's going to happen there with liquidity pools, decentralized exchanges, etc. So there's different types of things that are happening behind those liquidity pools, and there's different ways that people can figure out specifically what the ratio is for the exchange of liquidity you're providing, because certain currencies are valued more than others depending on the time of day and the supply-demand kind of situation. And you can see the supply-demand graph here of what that liquidity would look like. So at a high level, that's what decentralized exchange is, and that's what's happening there. So with this challenge specifically, our goal in this level is to basically hack this contract so we're able to drain it basically. So it's going to say that you're going to start with 10 tokens of token 1 and token 2. The DEX is going to have 100 of each, so they'll have 100 of each and we'll have 10 of each. Here we're going to say you're successful if you can manage to drain all of at least one of the assets of the 2 tokens. So we have to drain all the assets, not both, but only just one. And report bad price. Okay, cool. So we don't really need to worry about that piece. But the goal here is basically to drain at least one of the tokens. Here they're going to give some tips and tricks on what you should consider. Really the high level piece here is that the important thing to focus on is how the price is calculated for these tokens, because that's what we're going to manipulate in the end. They're going to talk about the swap method, which is the function we're going to specifically manipulate and exploit, which correlates directly to this. And the approved transaction. So this is where we ran into issues. We're unable to do this for some reason. Don't know why. All right, so that is the challenge. Here is our code. And before we jump into that, I wanted to call out a few things. So first things first is this individual is the one I was referring to. You can see they put up a Stack Exchange 7 days ago, and it was viewed 9 times, probably 8 of which were me or somebody else. But Roberto, sadly, ran into the same issue I ran into, and there's no answer as to why that is an issue. So that was a link I wanted to show, but also I wanted to call out the fact that this challenge specifically was added semi-recently, and it was added actually by a really good YouTuber. So you can see their suggestion of actually creating this contract. So they not only suggested it, but they actually created the challenge themselves and merged it into the master branch for OpenZeppelin's Ethernaut series. And then in addition to that, this is the YouTube that I wanted to recommend. I wanted to give a shout out to this guy because Patrick Collins does a great job at explaining a lot of Web3 concepts in depth. I honestly, I've watched a few of his really long videos. Let me see if I can find it. I don't know if it's here. Maybe it's on Free Code Camp. I don't see it here. But he does have a really, really long Free Code Camp video that is basically smart contract development for, it's like 7 hours or something ridiculous. So good YouTuber, good challenge, and it's really cool that he added this and contributed, which is, I think, pretty neat. Alrighty, so this is basically me explaining the thing I've already explained. This is something we'll get into later on, and here's some solutions. So the solutions I came across, there's a few. So this post had multiple solutions again. This one was an outdated solution because apparently this challenge historically, back in August 2021 apparently, they've updated it since. And back then there was no requirement of to which tokens that need to be swapped, because this line here was added recently, which basically states that you have to swap token 1 for token 2 or token 2 for token 1. You can't actually mint a new type of token such as malicious token and then have that malicious token then swap out token 1s and 2s. So that was one thing they changed, and this solution he provided was an older variant of that, so he actually went about this a different way because of that restriction wasn't there. But luckily they wrote a new updated post as of October 12th, 2021, and they basically updated that and walked you through how you can solve it with those restrictions that are applied. Additionally, here's another solution that wasn't as in-depth as the other one, but I just like the fact that they called out the specific formula of what we're going to manipulate, which I put here. This one here is another decent explanation. It's not too in-depth, but it's pretty to the point, and they also have a really good breakdown of specifically what's going to happen when you're swapping things back and forth. And then my favorite solution is going to be this one here. Reason being is they've actually done a great job of breaking down not only the explanation of what's happening and the weakness that we're going to exploit, but also they break down each of the swaps and the correlated differences between the tokens. And I'm probably going to rely on this to explain some of this stuff because they've depicted it really well to make it more intuitive for others to understand. So those are the solutions that I came across. Before we go into the solutions, as per usual, we're going to review the code. So in the code, we'll just walk through the whole thing. So here we have the compiler version, so 6.0. Remember, floating points no bueno, it should be static. We're going to import a few things. So safe math we've imported previously, so I don't have to really explain that. These two items here, the interface for ERC20 and ERC20 from OpenZeppelin, the reason we're importing these is because we need to use the methods from here to both mint as well as swap tokens and do a series of other things that you do with ERC20 tokens. Here's our contract called DEX, and in our contract we're going to use safe math later on, so we're going to bring that in here. We have two state variables for addresses, so we have the address for token 1, address for token 2. We have our constructor, which is going to leverage this. So we're going to take so when this is deployed originally from the DEX creator, they're going to put an address for token 1, they're going to put an address for token 2, and they're going to then tack those against these variables here, which is going to be up here. And if we go down a bit further, this is where all the magic happens. So all this green stuff, all this commentary is from me. I'm trying to think through specifically what's happening in each one of these lines. So I wonder if I should remove those so they're not so distracting. We'll keep it in there, just ignore it. So I think what we should do is we should go to swap last. So we'll skip swap because this is really where all the action happens. So let's go down here and talk through all the helper functions that are then referenced in the swap function up there. So here we have an add liquidity function that actually we don't use, but this would be used if we needed to within a DEX. And the add liquidity is basically pulling from another contract down here, but what's going to happen is basically if you've created a token, you can actually add that liquidity to this pool. So say we have a token and we've created it, and say that token is called malicious token. So we can say this, we want to add malicious token, and we want to add a certain amount of malicious token. So when we add that amount, what it's going to do is it's going to say, okay, this sender for this address wants to add this amount, and we're going to transfer from the sender to this address, which is the contract we're speaking about, and then we're going to transfer that number of malicious token to it. And then that's going to happen here. The next piece is get swap price. So get swap price is referring to the ratio of what you're going to swap. So if you're going to swap token 1 for token 2, you need to figure out what the price is correlated to that swap. Usually it should be different, not necessarily always a 1-for-1. But what we're going to do here is you're going to see that we're going to basically say from this address, which is going to be, say, token 1, to this address, which is token 2, and we're going to swap this amount. So we can say 10 of token 1 for token 2. It's a public returns, a UN, so it's going to return a UN. So the return statement's basically going to do a few things. So this is the formula that we're going to run through that I discussed earlier, or I showed you earlier. So here what you're seeing is happening is basically we're going to say I want to take this amount of 10, which is this. I want to then times that by the balance of the 2 address. So the token 2, so how much token 2 do we have to then divide? So we'll then say this is say T2, and then we're going to divide this by the balance of the address we're taking it from, which is token 1, balance of address. So this is the total supply of the contract. So remember we read that the total supply was 100. So what's going to happen here really is T2 is going to be 100. So if we scratch that out and say 100, and then T1, we know it's going to be 100. So we're going to say 10 times 100 divided by 100 equals the amount that we're going to, or the price differential between these two. And you'll see this makes more sense when I show you in the table, but that's the basic formula that's happening here. So we're saying address this refers to this address, the one that we're looking at now in this contract. And it's saying the balance of the 2, which is going to be the token 2. And then the same thing applies here. We're saying this address for this contract. We're saying the balance of the from, which is token 1. So that's going to be 100, remember, because we're both starting with 100 for the contract for both. And then we're going to say the amount that I've requested, which is 10. So that's the get swap price piece. Below that we have the approve, and this is where I ran into issues, sadly. So before you swap anything, you need to approve the fact that somebody can swap something. So the address we want to approve is going to be our address. So we're going to say, me, and then we want to approve a certain amount, which I originally tried 10, and then I tried a series of other numbers, but none of those worked. And then in here, there's a few things that are happening. So the swappable token is referring to this contract down here. And it's basically saying that approve the sender this amount for token 1, and then approve the sender for this amount for token 2. And that's the approval piece. If we come down to the contract, we'll do a balance of really quick. So balance of is just a helper function, right? So it's going to say how much does this contract have. So we'll say me, and then we'll say address account. Actually, no, that's the token. Sorry. So this is me, and then this is going to be token 1 or token 2. That's what this would be here. And it's a public views return, and it's just going to return the balance. So it's going to say this account has X amount of token left inside of it. And then the last piece is going to be this extension contract that we're going to basically call above here in the approve as well as in the swap that we'll talk about in a second. So the swappable token is it's inheriting ERC20, so it can use the methods of that. And one of the methods it's going to use is actually mint. So in the constructor, it's going to take a name for the token you want to mint, the symbol for that token that's going to be traded, and the initial supply of that token. It's a public ERC20, and it's going to return both the name and the symbol once this is completed. So you're going to mint, the sender is going to mint the initial supply, and that'll be returned. So that was actually how this post, the original post, the guy that has like the laser eyes, that was the first thing that he did, and then they had the restrictions added from the swap, which I'll discuss right now. So in our function swap, remember, this is where the magic happens, and this is what we want to manipulate. So specifically what's happening here is there's a few require statements. So this first require statement, and actually, so the swap is going to take a from. So it's going to say, I want to go from one token to another. So this is from 1 to 2, and then the specific amount that I want to swap. And it has a require statement, so it's basically saying that you can only swap token 1 for 2, or you can only swap token 2 for 1 and nothing else. So that's the new requirement they've added recently, which basically made obsolete the first solution that one individual showed us. The next require statement here is saying that the sender that's requesting the swap has to have either greater than or equal to the amount. So if they don't have enough to swap, then they can't swap it. Simply put here. And that's the error message you would get. And then below this, we're going to tell you the swap amount that's being requested. So you're going to say from token 1 to token 2, you want to swap 10. It's going to say, okay, the swap amount is 10. Below here, it's going to do the transfer from and then the transfer to, basically. And you can see that called out here, from and to. So the transfer from is saying, from this sender, I want to transfer to this sender this amount. So this here is going to be the contract, and this here is going to be me. And then the amount is whatever I want to put, so I'll say 10. Below here is saying the approval. So we're saying that this address, so this contract that we're sending it to, approved this swap amount to actually be sent. And that was the hiccup that we hit, and that's where we failed. And then below here is another thing, but it's swapping to. So it's saying from this address to this address, we're going to swap this amount. So if we've requested to swap 1 for 2 for 10, that means that the contract's going to have to send us 10 of 2 for the one that we've just exchanged. So that's what's going to happen in this piece here. So hopefully that was helpful and useful for a breakdown. It's quite a lot there. So we've talked through this, and we will talk through now the explanation. And the explanation I'm going to give is through this post because he's done such a good job at explaining it. So the first thing you need to know is that inside of, and I think I called it out here in my notes. Yeah, but in my notes here you can see it. So with Solidity, they actually aren't able to comprehend or leverage floating point values. So that means that we're unable to have decimals or fractions. So that means if we divide a certain number by another, if we get something like this, what's going to happen is it always rounds down to 24. And if that's the case, that means that there's a mathematical, conundrum that we can take advantage of as long as the price is as basic, or as long as the price correlation is as basic as we found it. So if we swap a few things around, you'll see that this rounding down factor, this issue of not being able to comprehend floating points, is what we're going to take advantage of. And that's something similar that they've explained here, so I'll zoom in a bit so you can see it. And here they're basically stating that division towards 0 rounds down, etc., etc. So if you do 3 divided by 1 or 2, you're going to get 1 instead of what you should get, which is like 1 point something 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 something. Cool. So that's the explanation there. And now let's get to their breakdown of what we're going to do here. So we're going to swap back and forth between our tokens until we can actually completely drain one of the tokens. So this is the DEX. So this is the contract of what they have, and this is us. So remember, we have 10 of both, and they have 100 of both. So our first initial swap is going to be basically, I want to swap all my token 1 for my token 2. And here you can say, we said we wanted to swap all of token 1 for token 2. So that means that we're going to request that the DEX, plays fair and does this such. So we can see after this first request, we're going to have something like this, where we've given up all of our 1 for 2, so now we have 20 of 2. And here you can see what happened here is that we've given them 10 of our 1 and they've given us 10 of their 2. So now it should be 110 to 90. Now after this you're going to start seeing some of the flaws where it should usually stick around 110 to 90 the entire time, or at least the correlation between what we're looking at between these should be the same, but it's going to start to falter quite a bit. So if we come down here, you can see actually they call out in their explanation here that when we request the next one, where we're basically going to say, I want to swap all my token 2 for token 1 after I've done this. So I want to say, originally I want 20 of 1 now. So I want to take all of this and move it over here. But when we try to do that, what's going to happen is that we're going to go through the formula up here, where we're going to say, okay, I want 20 of 1. So that means we're going to say, this is the amount that I want. This is the formula that we've already discussed previously. So the 2 they have currently is 110. The 1 they have is 90. So we're going to say this multiplied by this divided by this is going to come out to 24.444. Remember, it rounds down. So it's not going to give us 20 as we expected. It's going to give us 24. So that's where this kind of comes into play, where we've actually gotten more than we were supposed to get. We've gotten 4 more because the formula above is faulty, as well as the division is faulty because it rounds down and there's no floating points. So as we go through this, we'll continue swapping back and forth, and you can see they've broken it out here. So we did our original swap, we got our 24 back, and then we said, okay, now I want all of my token 1 for token 2. When we do that, it's going to go through the same formula above, but now you can see we've gotten back 40, which is more than we should have, 30 more than we should have gotten. Then we're going to swap this for this, and then we're going to get more than we should get here. We're going to swap back, we're going to get more than we should get here. And then the final ones, we're going to swap from 65 to this, to token 1. When we do this, you can see that our token 2 and their token 2 is actually different, and we have more than they have. So every time before this, they've always had more than we've had, but now we have more than they have of token 2. So when we do this, we're actually going to completely drain token 1 when we do this swap, because they're not going to be able to provide everything we want for token 2, or they're not going to be able to take everything, so we're going to be able to drain all of that out. And here you can see they've given an explanation here of walking you through specifically why that's the case. And we can see this final flip, when we go from 65 to 0, it's actually going to say, okay, I'm going to give you everything I have, plus more. So I'm going to say, okay, I'm going to give you the 45, and then I'm going to keep my 20 because I still have more than expected. So I'm just going to give them 45. And then when I do that, it's going to then drain their 110 all the way down, and I'm going to have all of token 1, and they're going to have 0 of token 1. So that would solve the challenge, because we've drained one of the options. And that's kind of the logic of how we're swapping back and forth. And this is, I think, called a flash loan, or something along those lines, where this commonly happens in more complex ways with actual dexes. So these are the steps that you're supposed to go through. So first, you're supposed to approve the fact that you can swap tokens, and once you've approved it, then you're going to basically, this is just a simplicity for simplicity's sake. You're going to take the address of token 1 and put it into a variable, address of token 2 put it into a variable, and then you're going to do your swaps back and forth. So you're going to say 20 or 10, 20, 24, 30. You're going to keep swapping back and forth as we explained above. And once you get down to the last one of 45, you're then going to take over the entire supply of token 1. But if we come here, I'll show you exactly what the issue is. And if you know how to fix it, that's great. Put it in the comments and let me know. So realistically, we should be able to approve ourselves. But when we try to approve it, MetaMask gets hung, and it just loads forever and ever and ever, and it never stops loading. So we can't actually do anything. We can't approve it. So if that's the case, if we try to swap anything, so if I go up, I'll see probably the swap here. So here you can see in this swap request that I've made, we can ignore that. That doesn't matter. All right, is this right? I have too many parentheses. Cool. So in this swap, you can see basically I'm going to take the address of token 1. So I'm going to say I want to swap this first address for this second address for this amount. So this should work because I have the balance, and I can prove it after I show you this error. And there you go. I've been declined, and my guess as to why I've been declined is that we've not passed one of the approval checks or the requirements, and it's disappointing. So, internet, with that being said, we understand the solution, we understand the problem, but we just can't implement the correct way of doing this. So, with that being said, I'll see you in Dex 2, which hopefully we can solve together.